Okay, moving on to 7.3. Now we have double angle formulas. So similar to compound angle formulas, you have another bunch of formulas to remember. Jot them down in your formula sheet. Turn to page 416. They're there listed. A quick derivation. We can use a compound angle formula that we learned in 7.2 to turn it into its compound angle formula expanded. Sine theta cos theta, and then it's cos theta sine theta. There's the same variable, theta and theta, instead of a plus b. So these are actually exactly the same. I could just rearrange this to say sine theta cos theta. Now that they're the same, I have two of them. I can collect them just like an x and an x, or an xy and an xy is 2xy. And this gives me my first double angle formula, sine of 2 theta. And this is the double angle. It's just an angle twice. I have other double angle formulas. I'm not going to derive them at all. You have to memorize them. There's 3 for cos. It's useful, but also annoying because you don't know which one to choose sometimes, but that's fine. And then we got tan 2 theta. Obviously, tan isn't a fraction because tan hates you. So let's try it out. We want to simplify each of the following. So here, sine 2 sine of pi over 8 cos of pi over 8. We have to link it to a formula here. I'm looking here. I notice it's this formula, so I'm going to replace it with this, where theta is pi over 8. So this is just 2 sine theta cos theta, where theta is pi over 8. Okay, now I'm not going to replace this with pi over 8 because that's the question. I'm going to replace this with sine of 2 theta. Theta is pi over 8. And this becomes sine of pi over 4. If I'm inside my argument, inside the function, okay, I can do math inside the function. Don't think of removing that math from inside the function. It's like bringing down the argument in a exponential function. You can't do that. Okay, so it has to stay inside there. This becomes sine of pi over 4, and this is root 2 over 2. And that's my answer. Okay, pretty straightforward. Similar to this, tan is honestly the easiest because it's obvious that you're using tan. There's not 2 of them like compound angle formulas. There's just 1 of them. So it's got to look exactly like this. Maybe sometimes it doesn't look exactly like it. You have to do some moving around to make it look like it. But this is just going to turn into tan of 2 theta, where theta is pi over 6. So I'm going to replace my theta. You don't have to use these square brackets. I'm just trying to not direct you away from inside of the function. This is just tan of pi over 3. And tan of pi over 3 is root 3. Okay, pretty easy. Okay, so here we're going to be determining the value of a trig ratio for a double angle. You're going to see where we can replace using our formulas. So all we know in this question is that cos of theta is negative 2 over 3. Before I even read the rest of the question, I like to have a visual. So when I'm reading the rest of the question, the visual can help me maybe crack the code in the rest of the question. It's more efficient to do it that way. So I'm just going to do this. I know here, I know here. It's got to be on the left side. It's negative. It's between 0 and 2 pi. My diagram holds. Determine cos of 2 theta and sine of 2 theta. Okay, so I have to find a formula to replace cos of 2 theta. And I have to find a formula to replace sine of 2 theta. I'll do second. All I have is this. Which formula would you choose over here? The middle one. 2 cos theta, cos squared theta minus 1. Why? Because I have a cos theta ratio. It's right here. I don't have sine. And because I don't have sine, I'm not going to use any of the cos 2 theta formulas that include sine. So it's very easy to choose the one that's not. So cos of 2 theta is going to be equal to this. Plug in the ratio. Cos theta is negative 2 over 3. I don't know if this is the first time you see a square in trig. It shouldn't be. But if the whole ratio is squared, then the ratio is squared. This becomes 2 times 4 over 9 minus 1. That's 8 over 9 minus 9 over 9, negative 1 over 9. So cos of 2 theta is negative 1 over 9. Easy, we don't have to do much in that one. Okay, let's do sine now. Do it on this side. Sine of 2 theta, well, that's an easy one. There's only one of them. 2 sine theta cos theta. I already know cos theta. It's negative 2 over 3. All I need is sine theta. We know how to find that. We've done it in chapter 6. We've done it early in this chapter. It's very easy, and you're going to do it very often. If you have a full ratio, you're going to use Pythagorean theorem to find other ratios. Okay, so make sure you draw your little triangle. If you're working over here, and cos is 2 over 3, we know that the adjacent is a 2, and the hypotenuse is a 3. 9 minus 4 is 5, so this is root 5. Okay, Pythagorean theorem. Whether you do it by inspection, whether you write it down, I don't know how you want to do Pythagorean theorem, but with integers that small, should be a one-step thing at this level. Okay, so I'm replacing sine theta with its ratio, which is what? Opposite over hypotenuse, root 5 over 3. Okay, I'm going to keep going for now. So this is just going to become negative 4 root 5 over 9. And this is my sine 2 theta ratio. Now, it's not fully right. The reason is, because we're in both these quadrants, because cos is negative in both these quadrants, if we're finding sine, there's 2 possible answers. There's positive, and there's negative. So however you want to think of it, you can think of the root 5 being positive and negative and changing it, or you can just think of, I know one of my sine ratios has to be positive and one has to be negative. So I'm going to do this twice, once with a positive root 5 over 3, once with a negative root 5 over 3. What's that going to do? It's just going to change this to plus or minus as well. Okay, so I have 2 answers there. 2 answers for sine 2 theta, 2 answers for cos 2 theta. Okay, don't forget that. Small little diagram, takes 5 seconds to make, helps me understand, ooh, I have 2 answers if I'm doing sine, plus and minus, can't be the same. Okay, next one. Same idea. I see tan of theta is negative 3 over 4. I've done this a million times, me personally, maybe you not so much, but as you gain experience, you're like, okay, well, I definitely know sine and cos if I have tan, because Pythagorean theorem. I'm restricted though. Okay, when I'm restricted, I like to draw a diagram like this. Can't be there. It's got to be between 3 pi over 2 and 2 pi. You might say, sir, why would I draw a diagram like this? I'm just going to draw the terminal arm in this quadrant because I know it's got to be there. It can't be anywhere else. Okay? But that might not be true. What if that's not possible? If I'm drawing this where I can't draw, and I have to draw in one of those quadrants, I'm like, whoa, something's wrong. This is not possible. So I know tan of theta is negative 3 over 4. That's opposite over adjacent, and that's a 3, 4, 5 triangle. That's an easy one for Pythagorean theorem. You might be thinking, why are you using Pythagorean theorem? You don't read the rest of the question. Because I generally know that when you're given a ratio, you're probably going to have to find the third side length. Okay, but we have to calculate the value of cos 2 theta. So let's get back to business here. Cos of 2 theta, none of them have tan, right? So I need to find a different ratio, sine or cos, in order to solve this. I'm not going to pick the one that's cos squared theta minus sine squared theta, because then I got to do 2 things. I don't want to do 2 things if I can do 1. So let's pick the sine one, because we haven't used it yet. 1 minus sine squared theta, and I got to find sine theta. Opposite over hypotenuse. Negative. Sine is negative there. If I was using cos, it's positive there. So be careful. Make sure you look. 1 minus sine theta is squared. 2 sine theta, I knew it. And that negative disappears, so that didn't make a difference. 1 minus 2, 9 over 25. 25 minus 18, all over 25. However you want to do that calculation, you want to split it into 2. I already did the 18 during this step. It's a 9 times 2, it's easy. And then I'm already doing the 25 over 25 with that 1. That's just how I do fractions, especially when there's 1s. It's easy enough. And this is just 7 over 25. I don't like to leave my answer like this. I like to conclude. I know it's not a therefore statement, but this is a conclusion. This is a nice summary. The question's asking for cos of 2 theta. Your conclusion should have everything in it. Cos of 2 theta is 7 over 25. Look here, I know what I'm doing.